Welcome students, this is my new video on differentiation for the class 12 students of Mathematics and Statistics of Maharashtra State Board. We are studying the examples from the exercise 1.2 and so far we have solved questions up to question number 9. This is the last question, question number 10. In this question we see some special type of examples, and to solve these examples I have shown some examples here. You can see tan inverse of 7x upon 1 minus 12x square, or tan inverse of 3x upon 1 plus 70x square, or the last one in terms of cot inverse. So all these examples and few more examples will be there. We shall discuss those later on. These examples we want to differentiate them with respect to x, but before differentiation we need to simplify these expressions, and for the simplification purpose we need some formulae which I have listed in the upper part of the screen. See some useful formulae. Tan inverse of x plus y upon 1 minus xy is tan inverse x plus tan inverse y. If you consider x minus y and then divided by 1 plus xy, then it has tan inverse x minus tan inverse y, that is the RHS. Then the second formula is tan inverse of 2x upon 1 minus x square is equal to 2 tan inverse x. This actually is found from the first formula, tan inverse of x plus, suppose you replace this y by x, it will be x plus x, that is 2x, divided by 1 minus x into x, that is x square. 1 minus x square is tan inverse x plus tan inverse x is tan inverse 2 tan inverse x. You can remember it whichever way you want. Then tan inverse of 3x minus x cube upon 1 minus 3x square is 3 tan inverse x. And last one is useful especially for the third example. You can see cot inverse of a upon b is equal to tan inverse of b upon a. That means you can write this example in a different manner as tan inverse of 8x upon 1 minus 15x square. In this manner we can solve these examples. We shall practice these examples one by one. So let us start the work. See the first example, y is equal to, we have to take it y equal to tan inverse of 7x upon 1 minus 12x square. So we shall rearrange it before differentiation. So we shall write y equal to tan inverse of 7x should be rearranged and 1 minus. Now I shall look at the formula tan inverse of x plus y upon 1 minus xy, because it looks like that, this negative sign is there. So x into y, this 12x square can be written as 12x square can be written as 4x into 3x, and this 7x can be written as 4x plus 3x. So if you look at this expression, x plus y upon 1 minus, that fits here. 4x plus 3x, that is 7x, upon 1 minus 4x into 3x, that is 12x square. So in this manner we can write this expression again as 7x written as 4x plus 3x and divided by 1 minus 12x square written as 4x into 3x. And then it becomes similar to this expression, which is equal to, this expression is equal to tan inverse of x plus tan inverse of y. This is the formula which I had just talked about earlier. This is that formula. This formula is used here. So carry on. Now this is equal to, as per the formula, it is tan inverse of x plus y. So tan inverse of x means 4x plus tan inverse y, that means tan inverse of what? 3x. This is y in the simple form. Now we can differentiate this with respect to x, and you will get dy by dx is equal to d by dx of tan inverse 4x plus d by dx of tan inverse of 3x, and you can find these derivatives because you are now familiar with this kind of examples. What is divided of tan inverse of 4x? You need to know the tan inverse x's derivative, which is 1 upon 1 plus x square. So derivative of tan inverse x, the derivative is 1 upon 1 plus x square. So derivative of tan inverse 4x will be 1 upon 1 plus 4x bracket square into d by dx of 4x. 1 upon 1 plus 4x bracket square, which will be 16x square, into d by dx of replacement of x when you compare this tan inverse x with tan inverse 4x, plus in the same manner this derivative is 1 upon 1 plus 3x whole square into d by dx of 3x. We can write those steps to finish this as 1 upon 1 plus, what is this, 4x whole square is 16x square into d by dx of 4x is 4. That's the first term, plus 1 upon 1 plus this 9x square into d by dx of 3x is 3. Now we can write this everything as dy by dx is equal to this 4 upon 1 plus 16x square, and second term plus, what is that second term, 3 upon 1 plus 9x square. So this is the derivative we wanted. So that's it. This question's over. Let us see the next question. Second question is, this is dealt with. The second question is tan inverse of 3x upon 1 plus 70x square. So like we split this 12x square into 4x into 3x parts, these two parts, and 4x plus 3x, because this was minus sign, so I needed addition. If it is negative sign in the denominator, I need addition of two terms, which should be 7x. Here 1 plus 70x square plus sign tells us that this second formula is going to be applicable. So x into y. So how do you write 70x square in the product form? What? 10x into 7x. That will be 70x square. And 10x, and there should be subtraction of the two terms in the numerator. 10x minus 7x is 3x. So we can use these two and complete this answer. So let us write this answer. Now we have y is equal to tan inverse of, it was 7x plus 7x minus 10x minus 7x, so it will be 3x it was, divided by 1 plus 70x square. That was the question. So we write that as tan inverse of 10x minus 7x, that is 3x, upon 1 plus 10x into 7x. Now this is written by the formula as tan inverse of x minus tan inverse y, that is tan inverse of 10x minus tan inverse of 7x. This is why now we can differentiate with respect to x, and I will get dy by dx is equal to d by dx of tan inverse 10x is 1 upon 1 plus 10x whole square into d by dx of 10x, that we have done already in the last example, minus tan inverse 7x's derivative is 1 upon 1 plus 7x whole square into d by dx of 7x. And what do you think this is going to be? This is going to be, this d by dx of 10x will be 10, I'll write it in the beginning, 10 upon 1 plus 10x whole square is 100x square, and minus, what do you get in the second term? D by dx of 7x should be understood first, and that is written as 7 divided by 1 plus this 7x whole square is 49x square. That's it. This is dy by dx for this example. Let's see the next example. The next example is cot inverse of this one. Cot inverse of 1 minus 15x square upon 1 upon 8x. How do you rearrange it? This is written in terms of tan inverse as tan inverse of what? 8x upon 1 minus, we discussed this, 15x square. Now think about the two numbers whose product is 15x square, and now this difference, so numerator should be having plus sign. Addition 8x and product 15x square. Addition 8x 5x plus 3x and product 15x square, 5x into 3x, that is 15x square, that's in the denominator, and 5x plus 8x in the numerator. So if you write this cot inverse in terms of tan inverse, this is written as 8x upon 1 minus 15x square. Then as usual, the last two examples we discussed, and we used this formula. Once we used positive sign in the numerator. In the second example, we used negative sign in the numerator. So you can solve these examples. Then some more examples are there in the exercise. Let us see those. In this example, we have to differentiate tan inverse of 2 raised to x plus 1 upon 1 minus 4 raised to x. I have written this here, which is rearranged as tan inverse of 2 raised to x plus 1 means 2 raised to x into 2. 2 raised to x into 2 raised to 1, that is 2 raised to x plus 1. And I can write this 4 raised to x as 2 square raised to x. You can do it anytime you want, which is going to be equal to tan inverse of, this will be written as 2 into 2 raised to x, one and the same thing. Denominators now 1 minus, how do you see this? 2 raised to x, a raised to m raised to n is a raised to n raised to m also. A raised to m raised to n is equal to a raised to n raised to m. They both mean the same thing. So here you have 2 raised to x is 2 raised to x raised to 2, which is equal to 2 raised to mn, 2 raised to 2x here, which is equal to a raised to mn. That means 2 raised to 2x also it could be written, but we don't want that. Now you can compare the formula. Tan inverse of 2x upon 1 minus x square is equal to 2 tan inverse x. This formula can be compared there to see. It is tan inverse of 2x upon 1 minus x square is 2 tan inverse x. Tan inverse of 2x upon 1 minus x square is 2 tan inverse x. So what is the value of x here? 2 raised to x. So instead of 2 tan inverse x, we'll have it equal to 2 tan inverse of 2 raised to x. And therefore it will be now easy to differentiate. This is y equal to 2 tan inverse of 2 raised to x. If we now differentiate it with respect to x, I will get dy by dx is equal to d by dx of 2 tan inverse x. Out of that, 2 is a constant, and then tan inverse 2 raised to x remains. So 2 is a constant, that is written in the beginning, into d by dx of tan inverse 2x. d by dx of tan inverse 2x is 1 upon 1 plus 2 raised to x square into d by dx of 2 raised to x, which is equal to 2 upon 1 plus 2 raised to x square is 2 raised to 2x also, or even you can write this as 2 raised to x square means 2 raised to x, which is 4 raised to x. So I may write that as 4 raised to x also if I want, and then into d by dx of 2 raised to x is 2 raised to x log 2. And then see this new example. Differentiate with respect to x, tan inverse of a plus b tan x upon b minus a tan x. Here we have to take it as y first. That's the initial step that we normally do. Then we have to rearrange this expression inside the bracket in such a manner that we can use the formula tan inverse of x plus y divided by 1 minus xy is equal to tan inverse x plus tan inverse y. Or tan inverse y, or we have to use tan inverse x minus y divided by 1 plus xy is equal to tan inverse x minus tan inverse y. One of these formulae will be helpful over here. So let us try to rearrange this and write it in one of these two forms. So which will be better? Now see this position 1 and here that position is b. So try to make this 1 by dividing this numerator and denominator by b. This is the usual trick. You will use it many times hereafter. So be familiar with this. Tan inverse. Now I am dividing both numerator and denominator by b. So what will happen? A upon b plus b tan x upon b is only tan x divided by denominator also b upon b is 1 minus a upon b tan x. That means a tan x upon b. One and the same thing. A upon b tan x. What we have done here is we have divided by b. Both numerator and denominators have been divided by b. So due to that arrangement, now we can compare this expression with this expression and we shall use it plus minus type. So tan inverse x plus tan inverse y. So what is this? Tan inverse of x plus y divided by 1 minus x into y. So I would write that as per the formula. As per this formula, it will be tan inverse of x, that means a upon b, plus tan inverse of y, that is tan x. Now tan inverse of a upon b will not change. Tan inverse of a upon b as it is, but we can surely change this term. Now this term is this tan inverse of tan x is just x. Tan inverse of tan x is x. So this is the simplified form of y. Now we can differentiate with respect to x so that we can get dy by dx is equal to d by dx of tan inverse a upon b. D by dx of tan inverse a upon b. Normally we use it's a wrong thing, but normally students make that mistake. Tan inverse a upon b, its derivative is found by tan inverse x's formula, 1 upon 1 plus a upon b whole square into d by dx of a upon b. That will give you the answer 0 only, but that is not the correct way. We can use, we should understand that this tan inverse a upon b doesn't contain any variable. That means it's a constant, and constant's derivative is 0, and plus derivative of x, it is 1. So answer is dy by dx equal to just 1. So this arrangement of division by b, this number has to be considered, and then divide both numerator and denominator by this number of or this term and get 1 there, because in both the formula this position tan inverse x plus y or x minus y, this position is always 1. So we have to get 1 in this position, and therefore we divide both numerator and denominator by b. So you can solve this. The answer is dy by dx. This is another example from the same exercise. differentiate with respect to x, cot inverse of 4 minus x minus 2x square divided by 3x plus 2. Now we can use the formula of the one which we used in the last example, tan inverse of x plus y or x minus y type, tan inverse of x plus y upon 1 minus xy, or tan inverse of x minus y upon 1 plus xy. This type of example, this type of formula is equal to tan inverse x plus tan inverse y or minus tan inverse y. That depends on the sign on the left side. So we have to use one of these two formulae. So for that we'll have to convert this expression in terms of tan inverse instead of cot inverse. So it's a very easy thing. We can write that as tan inverse of, how do you do this? Cot inverse a upon b is tan inverse of b upon a. That means this 3x plus 2 will go up, divided by denominator will be, this original numerator will become now denominator, 4 minus x minus 2x square. Now tan inverse of arrangement is done. Now we shall try to use this formula. Now here again I have to get 1 somewhere here and minus the product. So this is a special example. It's asked in the board exam a couple of times. So be careful about this. It's a very tricky one. I won't change the numerator in the beginning. Let's talk about denominator here. Now here I have to get 1. So add and subtract 1 there. Already 4 minus x minus 2x squares there. Take extra 1 and minus 1. That 1 can be used. This 1 is going to be useful. So I shall write that as tan inverse of, no change in the numerator yet. In the denominators though, we have many things to do. 1, then the remaining 3 and this fourth term. This 4 minus 1 is 3. So it's plus 3. Then minus x, then minus 2x square. All the terms have been written. This one which we wanted here in this formula is found. Now how do you look at these three terms? You have to look at this expression as sum or difference. It's plus here or minus. I'll check it. It can be minus sign also. Here after 1 they can be plus or minus. It looks to be 1 here, but that won't be the case in the end. See this, tan inverse of 3x plus 2 upon 1, and then these three terms are there. I have to write them by taking x square sign, by making x square sign positive. So I have to keep this negative sign outside. Then that minus 2x square will become plus 2x square. Minus x will become plus x. And plus 3 will become minus 3. Now look at this expression and try to factorize this. If you factorize this, what will you get? 2x square plus x minus 3. How do you factorize this? This can be factorized by taking a product 3 into 2 minus 6 here, which is written as 3 into minus 2, so that the product is minus 6 and the sum we wanted is plus 1. So you can still factorize it and write it as 2x square. I shall do it here itself, which is equal to tan inverse of 3x plus 2 divided by 1 minus 2x square plus 3x minus 2x minus 3. Carry on this simplification and the factorization process, and you will find it equal to y is equal to tan inverse of 3x plus 2 upon 1 and then the factorization minus, I can take these two terms together to have x common, and then you have two x plus 3 inside. And then from the remaining two terms, if I take minus 1 common, it will be again 2x plus 3 inside the bracket. Just understand this. This is going to be simplified as tan inverse denominator is important, 1 minus 2 factors are, one of them is 2x plus 3 into other factor is x minus 1. And the numerator, try to write this numerator in terms of these two. See, 2x plus 3 added with x minus 1 gives you 3x plus 2. So if you write these two together like this, 2x plus 3 plus x minus 1, what is that going to be? 2x plus 3 plus x minus 1 is 3x plus 2, which is there in the original numerator. So that's what we do here. So we converted this original expression, cot inverse of something, into tan inverse of something. Then we even wrote this as tan inverse of x plus y divided by 1 minus xy. Now it fits in the formula which we are familiar with, and therefore we can now write that as y is equal to tan inverse of 2x plus 3, formula is going to be used, plus tan inverse of x minus 1, because it's tan inverse of x plus y divided by 1 minus xy format. So it's tan inverse x plus tan inverse y, and therefore now differentiating with respect to x, we get dy by dx is equal to d by dx of tan inverse of 2x plus 3 plus d by dx of this, d by dx of tan inverse of 2x plus 3 is 1 upon 1 plus 2x plus 3 square into d by dx of 2x plus 3 plus similar differentiation of this term, 1 upon 1 plus x minus 1 square into d by dx of x minus 1, which is equal to 1 upon 1 plus 2x plus 3 whole square into d by dx of 2x plus 3 is just 2, and plus 1 upon 1 plus x minus 1 square into d by dx of x minus 1 is 1. So finish this as this 2 upon 1 plus 2x plus 3 square plus this 1 into 1 is 1 upon 1 plus x minus 1 square, and that's enough, dy by dx. So in this manner you can solve the remaining examples. Some examples of this type are also there in the exercise. So exercise 1.2 is completed here. So next time we shall see the next exercise. Till then, practice this exercise 1.2. Thank you.